So in this video we have a radical equation to solve. This one involves a fourth root. We want to find the real solution of the equation. Now if we're dealing with a square root, we simply isolate the radical and square both sides. Here we're dealing with a fourth root, and the fourth root expression is already isolated, so I can take this side to the fourth power, this side to the fourth power, eliminates the radical. So this becomes 4 minus 5x squared is equal to x to the fourth. Taking both sides to the fourth power, and then I'm going to take these terms over to the right side, and then this becomes x to the fourth. This comes over, becomes a plus 5x squared. 4 goes over, it's minus 4. I could have the equal 0 over here, but I just leave it over here. So I got x to the fourth plus 5x squared minus 4 is equal to 0. You can solve it the way it is. If you want to use a substitution, I'm going to write this in quadratic form. So I'm going to let x or y equal to x squared. Then this one right here would be x squared, and the x squared is going to be your y. So let me just do it this way. It's be y squared, 5y minus 4 is equal to 0. Now, you can do it without the substitution. You can do it. Go ahead. This one doesn't factor, so I'm going to use a quadratic formula. So I'm looking at it as a quadratic equation in the variable y. So I can just say that y is equal to minus b. Okay, this is your b, coefficient of the, in this case, the linear term y. So that'll be minus 5, and it's plus or minus the square root of b squared, and b is 5, so that'll be 25, minus 4, a is 1, and c is negative 4. And this is over 2 times a is 1, so this will be 2. So let's simplify the expression on the right side. So y will equal to minus 5 plus or minus the square root. So it'll be 25 here, and then minus 4 times minus 4 here. This is 16, because you have a 1 there. Plus 16, and a 25 is 41. And that's over 2 times a, and that gives us a 2. So here's the situation then. We have a y squared, but we're going to go back to the original variable, and y is equal to x squared. So let's put, instead of y, I'm going to put x squared here. So instead of y, I'm going to have x squared. So here's the situation we can have minus 5 minus the square root of 41 over 2. Minus 5 over the square root of 41, but that's going to be a negative. You can't have x squared equal to a negative here. So that'd be a non-real number. We only want real solutions here. So the only choice we have here is that the value of y, which would be the value of x squared, will be a minus 5 plus the square root of 41 over 2. Then we take the square root of this. Square root of x squared on this side will give us x. And on the other side, you write the square root of that, minus 5, plus the square root of 41. And that's over 2. We can't have a plus or minus here because whatever we have on the right side has to be positive, because we have a fourth root over here that's understood to be a positive value. So this is the only possible solution, real solution, that we can have. So x equal to the square root of minus 5 plus the square root of 41 over 2 appears to be the only real solution. And the hard part of this is going to be to check it. So let's go through the setup here for the check. So we get this solution right here, x equal to the square root of minus 5 plus the square root of 41 over 2. So we're plugging it in to this equation right here. So that answer is going to be plugged in for x here. Then we're going to square it, combine it with the 4, take the fourth root, and it's supposed to give us x. And of course, what is x? X is the original solution. So you can see it easier here. I went ahead and set this up like this. So it's the fourth root of 4 minus 5, and it was x squared. And this is x here. And based on what we saw there, whatever we get has to be x, which is the same thing here. So let's do it right here. We get 4, and then we square this. Remember, we're inside the radical there. We square this out, and that simply eliminates the radical. Makes this a minus 5 here. Of course, the radical inside still stays, because this square only applies to the outer radical. So this is the square root of 41 here. And of course the 2 is under there, so this stays like that. And then we combine this out. So this is all going to be over 2. And let's multiply here by 2 here. And 2 here. Get a common denominator, so this will be 8 then. 2 here. So this will be 8. Then minus 5 times a minus 5 is a plus 25. Now minus 5 times radical 41 is minus 5. Radical 41. And then these two add up together. 8 and 25 is 33. And I get 33 minus 5 radical 41 over 2. So we get that. So that's okay. Now, from here, from the Peirce result, we have 33 minus 5 square root of 41 over 2. And what I did here, you can verify this. So we got to this part where we plugged it in here. And then I got x squared here. We got the x here. 4 minus 5x squared. Plugged it in there. And we're to this point right here. So what I'm saying is that if I take the square of this expression right here, I get this right there. And you can check it out again. Pretty much the same sort of thing I just did. If I square this out, I'm going to get what I have here. So those steps are in sync. Now to go from here to here, here to here, I have a square here, and this is the 4th root. So if I take the 4th root of this, all that does is makes it a power of 1/2. Notice, because if I bring this over, this would have to be, the exponent would be 2 over 4, which is a 1/2. So it would be this expression right here to the 1/2 power. Well, I can write it as the square root of minus 5 plus the square root of 41 over 2. And of course, that is your x. In other words, if I plug in the value of x into the equation, it does check, because on the right side, I get the value of x again, which is the square root of minus 5 plus the square root of 41 over 2. So that checks. Thanks for watching. We'll see you next time.